Good afternoon, everyone. I'm sorry that I have to be gone today, but with the boys crosstown soccer this afternoon, I have to be gone, and so I've recorded a lesson for us. To start, we're going to do the daily trivia question. Daily trivia question is, how many grooves does a quarter and a dime have on each of them? Well, you take a guess. It turns out quarter has 119 grooves and a dime has 118. More interesting kind of question, though, is why do they even have grooves? And it has to do with the history of counterfeiting. So before the 18th century, the U.S. Mint began adding ridges to coins' edges, a process called the reeding, in order to make it impossible to shave them down without the result being obvious. So what would happen is people would shave off a little bit of coins. If you shaved off enough of a little bit of coins, you melt them all down, you can start to make extra coins from the fringe of the ones that you shaved. So as a side benefit, the reeded edges also made coin design more intricate and counterfeiting more difficult. So that's why we added grooves, was to tell if a coin had been shaved down. So today we're going to be working on P.4. Yesterday we did P.3 and the answers for that are shown right here. So please have your homework out. I'm going to briefly just read off what those answers are, and then we'll get started with today's lesson. So in P.3 we are working on simplifying radical expressions and working with rational exponents. Question number 7's answer was 3, 9 was 1, 13 is 5 times the square root of 2, 21 is 2x times the square root of 3x, 33 is 13 times the square root of 3, 41 is 34 times the square root of 2, 83 is 6, 85 is 2, 87 is 25, 93 is 4x to the quarter, 118 is 0.44 RF, and 100 weeks. And 118 was a challenge one, so if you didn't get it, don't worry too much about it. But there are your answers for P.3. If you would please, have out your note packet to P.4. What we're working on today in the prerequisite chapter that the Helena College requests that we do is we're working on reviewing how we add, subtract, and multiply with polynomials. So have that note packet out. I'm going to get my copy so I can see what you're looking at. And it's in section P.4. So at the very top left, I have a warning though. And it says, be aware what we're working on today is adding and subtracting these guys. So x cubed plus x cubed is what we're working on today. What we worked on a few days ago was this. So we're going to review just what we did prior. When I'm multiplying and I have exponents, I add my exponents. We learned it would be x to the third times x to the third is x to the 3 plus 3. That makes x to the 6. That's what we're working on. But what we're working on today is not multiplying, but adding them. So here I have 1x cubed plus 1x cubed. That makes 2x cubes. So just notice the difference between when I'm adding and when I'm multiplying with these. To start, we're going to go back in time to kind of grade school, remind ourselves how we added with these types of numbers, because the process can be very similar to what we're working on today. So how did I add when I had decimals? Well, I would simply write them out like so. 1,304.25, and when I added these, it was important to know you do not do what I am doing right here. You do not just simply line up the leftmost with the leftmost. What you need to line up is your decimal place with your decimal place, and the reason why is because you need to be adding like terms. They never said that in grade school because it didn't mean anything to you yet because you hadn't even learned about a variable. But you are adding like terms. I need to line up the thousandths with the thousandths. Now my hundreds, that's why the 8 goes in the hundreds. Then 21, line up my decimal place. 3 is in the tenths, 9 is in the hundredths, 1 is in the thousandths. And then I'm going to be adding. Okay, if I don't have a number in there, we use a placeholder of 0. We'll do that today as well. And now I simply add my like terms. You know, the rest isn't really important. There's no such thing as carrying over that we'll have today in terms of polynomials, but the process of lining up and adding our like terms is going to be similar. So lining up and adding our like terms. So answer is not important. What is important is that we line up our like terms, and that's what we're going to be working on today with polynomials. So before we go doing that, we're going to define a couple of terms that we're going to be using throughout the lesson. The first one is a polynomial. Polynomial is an algebraic expression that is the long strand of the sum or differences of individual terms, like so. So I'll give you an example right there. I'll give you a second to write that down. I'll read it off one more time. It's an algebraic expression that is the long strand of the sum or differences of individual terms, like so. 7x to the fourth minus 5x cubed plus 1x squared plus 9x minus 12. Polynomial, the word itself, if you don't need to write this part down, it's just for you to know. Poly means many, like if I said a polygon, that's a many-sided shape. So poly means many, and nomial, in this case, it comes from the word meaning name. like nomenclature in biology. It's how we name things. So polynomial is something that has many names. We mean many terms. So that's what a polynomial is. A degree is the largest exponent in the polynomial. In the example above, the largest exponent that we have is a 4. So we would say that that polynomial is a degree 4. The leading coefficient, well, coefficients are the numbers in front of our variables. So we have 7, -5, this is a 1, and 9, those are all coefficients. The leading coefficient is the coefficient of the term associated with the degree. It's how many we have of the highest power. So in this case, the leading coefficient would be the number 7. Okay, those are our 3 terms for today. We're going to start off by working with just adding and subtracting these guys. So when I'm adding and subtracting, it might be wise to line up and look at your like terms. So I look at the degree. The degree of both of these polynomials is degree 2. It's the highest power. So I'm going to make an x squared column. I'm going to make an x column, and I'm going to make a 1's column. In this case, it's not as beneficial to really line it up because they perfectly match with each other. You could almost just add these kind of side by side, but it will be beneficial in later ones when there's some missing pieces. So I'm going to start the process now, just good habit to develop. So here's the first one, -3x squared minus 8x plus 5. And I am adding, so put a plus sign out. Second one is 1x squared, so I'll even put a 1 there, minus 6x plus 2. Now all I do, same as what you were doing in grade school when you're adding decimals, is add my like terms, add my 1's. 5 plus 2 makes 7. Because it's positive, I'll put a plus. -8x minus 6x is minus 14x's. Last part, -3x squared plus 1x squared is -2x squared. And then I'm done. I can't add any more because they're not like terms. This is counting x squareds, x's, and number 1's, just like you wouldn't ever combine your numbers after you added your decimals. So there's the first one. Okay. Give you a second to write down any last parts that you might have missed. And then moving on in 3, 2, 1. Okay, second one. This one we're dealing with a subtraction. Here the degree of both of these is 3. So my highest power is going to be a third. So I'm going to write q cubed column. There's going to be a q squared column. There's going to be a q column. And there's going to be a 1's constant terms column. So I should have 4 columns here. My first one is a 1q cubed minus 7q squared minus 3q, and I don't have any 1's, so I put plus 0. There's my placeholder. Now, this is important. I'm going to be subtracting 1q cubed plus 10q squared plus 0q. So there's a placeholder. There's no q's in the second polynomial, minus 4. And now all I need to do is add or subtract my like terms. Okay? And this is important. I'm dealing with subtraction for all these, so you have to read it off. I have 0 minus a -4. 0 minus a negative makes plus. So this is really going to be plus 4. -3 minus 0 will be minus 3q. -7 minus 10 is -17q squared. And the last one, 1 minus 1 is 0. And I'm all done. So there's my answer. If you want to, you could actually change the subtraction question to an addition question, but what you'd have to do then is change the signs of everything in this second polynomial. So this would be a negative, this would be a negative, 0 would stay 0, and then this would become a plus. And then you could check it. 0 plus 4 is 4. -3 plus 0 is -3. -7 plus -10, -17. So if you want to, you can change any any subtraction to an addition, as long as you change the signs of the second polynomial. Okay, that's adding and subtracting. I'm going to give you a chance to try. So, if you would please, plot your whiteboard. Once everyone has their whiteboard out, pause the video, give everyone about a minute and a half to try it on the whiteboard. Once you've had a chance to try, check with a neighbor, and then we'll briefly go over it. So pause video now, please. Okay, welcome back. The answer you should have got is -9x cubed minus 9x squared plus 3x plus 5. I'm just going to show what it should look like if you lined everything up. So if you lined everything up, it would have been -5x cubed minus 2x squared plus 0x's plus 7. The second one, we're going to be subtracting. It's going to be 4x cubed plus 7x squared minus 3x plus 2. And if you wanted to, you check it. Each piece is going to work out, but if you want to, you can change this to be an addition, but you have to change the signs of all these second terms in the second polynomial. Okay? Okie doke. Moving right along. We've done addition and subtraction. We're just working our way through the operations that we did with numbers. In grade school, you learned how to add and subtract, then you did multiply and divide. We're doing the same thing with polynomials here. We know how to add, we know how to subtract. Now we're going to talk about multiply. And so before beginning and jumping all the way into multiplying with polynomials, we're going to review what we did when the polynomials were a little smaller and all we did was distribute. Like if I had a 5 here, I would just multiply it through. I'd get 5x plus 15y. If there was a 5x with it, the x comes along. 5x times x is 5x times x is x squared. 5x times 3y, well 5 times 3 is 15. X times y we just write as xy. So I'm just distributing. And that's all we're going to do in the next cases. If I want to multiply this polynomial right here in blue times this polynomial in red, I'm going to do what's called double distribution. You might have heard this called FOIL before. So I'll show the distribution method first, and then I'll show how you can use a table method to get the same answer. So I'm going to write out 2x plus 1 times 3x minus 4. And all I'm going to do is distribute one term at a time. So 2x times 3x, that's the F in FOIL. It stands for first. First times first. 2x times 3x is 6x, so we get 6x squared. Okay. Now 2x needs to distribute to negative 4, and that makes minus 8x. And that's the outside terms. So the FO of FOIL. Now the 2x is done distributing. It will never multiply the 1 because it comes from the same polynomial. So now the 1 distributes. That's why we call this double distribution. There's two things that are being distributed twice. 1 times 3 is 3x, and 1 times minus 4 makes minus 4. That's the I is inside, and then we do the last terms times the last terms, and that's where we get the term, the acronym FOIL, FOIL. Now all I need to do is combine my like terms, 6x squared. My like terms are right here in the middle. Minus 8x plus 3x makes minus 5x, and then minus 4, and I'm done. That's how I multiply with these polynomials. If you want to, you can make a little table for it. 2x plus 1 over here, 3x minus 4, and then just multiply like it's an old school multiplication table. 2 times 3 is 6, x times x is x squared. 3 times 1 is 3, x times 1 is x. 2 times negative 4 is minus 8, x times 1 is x. Negative 4 times 1 is negative 4, and then all I do is combine my like terms, and my like terms are always going to be diagonal from one another. And when I do that, I'm going to see I get the exact same answer as over here. So it doesn't matter which tool you use, it's just you have to make correct mathematical steps. So there's one example. We'll do one more. Now what if I have a trinomial? We call this a trinomial because it has 3 terms times a binomial. Well, first thing is, can I use FOIL here? I can't. FOIL is only used if you have a binomial times a binomial because you're going to get 4 terms here. Here we have a trinomial times a binomial. We're going to have 6 terms. So I can't use the acronym FOIL here. I have to really think about it as like triple distribution. Okay? So I'm going to write it all out. X squared plus 3x minus 4 times 2x plus 3. I just need to distribute each of these in the trinomial twice. So x squared times 2x is 2x cubed. Then x squared times 3 is 3x squared. Now the 3x is going to go. 3x times 2x is 6x squared. And 3x times 3 is 9x. Last thing to go is the negative 4. Negative 4 times 2x is minus 8x. Negative 4 times 3 is minus 12. Now I just need to combine my like terms. There's like terms here and here. There's like terms here and here. So I have 2x cubed plus 9x squared plus 1x minus 12. And I'm all done. That's if I use the multiple distribution method. If I use a table method, my table needs to be 3 by 2 because it's a trinomial times a binomial. So I'd have x cubed here, 3x here, minus 4. And something I should mention is it doesn't matter how you draw your table. I could have just as easily drawn it, like that, and it would work out. The orientation doesn't matter. Okay? 2x plus 3. And I just go multiplying it through. So 2x cubed, 3x squared, 6x squared, 9x. Negative 8x minus 12. You see I get the same 6 pieces that I got over here, and I just combine my like terms, and my like terms are going to be, diagonal from one another, right there and right there. And I get the exact same answer that I had when I combine them as that. It's just a different method. Okay? There you go. That is multiplying with polynomials, you can either use the distribution method or the table method. I'm going to have you try this one real quick. So last yo-yo of the day, on your whiteboard, pull it out. This should take no more than maybe 30 seconds. Check with a neighbor. There's something semi-interesting that happens with this one that we haven't seen before. So pause the video now, come back once everyone's had a chance to try it. Okay, welcome back. Let's give it a go. Double distribution, you could think of this as FOIL. First times first, I'd get 16x. Outside, 4x times 5 is going to make 20x. Now the negative 5 will distribute. Negative 5 times 4x makes minus 20x. And negative 5 times positive 5 makes negative 25. And if I look, the interesting thing here is the middle terms cancel out. We get 16x squared minus 25. We call this a difference of squares. Why is it a difference of squares? It's a difference of squares because it's subtraction. We call that a difference. And if I notice, on each side, we have squares. 25 is 5 squared, which was the 5 times negative piece. And then 16x squared comes from the 4x being squared. That's why it's called a difference of squares. That'll happen anytime you have two polynomials, two binomials, I mean. They look the exact same, just one's plus and one's negative. So there you go. Last thing I want to point out to you is this. A lot of people try the following. Is x plus 6 squared the same as x squared plus 36? A lot of people try to like distribute this power here. Well, it turns out we can check it. It's not going to be true, and this is why. To square means to multiply something by itself. X plus 6 squared means x plus 6 times x plus 6. And if I double distribution this out, I'm going to get x times x, which is x squared, so this piece is good. X times 6 makes 6x. Then this will go 6 times x makes 6x. 6 times 6 makes 36. And when I add up all the pieces, I'm going to get x squared plus 12x plus 36. So I see that is not the same as this side. So no, I can't just simply distribute my power. I actually have to double distribute or FOIL it out to get the correct answer. This is the correct answer, so just be aware of that. Okay? A lot of people try this shortcut, but that shortcut is not true. It is not valid. That is it for today. You are working on the assignment for P.4. The answers for that are right here. So as you work, if our guest teacher would be kind enough to kind of maybe leave the video paused right here, it would be appreciated. And I will check both assignments when I'm back. So I'll check both P.4 and P.3 when I get back. So there's P.4. Okay, thank you very much and have a good day.